Welcome back, chemistry students. In our last screen lesson, we learned what a mole was, that it's a convenient unit to talk about things in chemistry because atoms and ions and molecules are so tiny that we talk about a very large number of them, 6.02 times 10 to the 23 of them, actually. Now, today, because we're often talking about things in moles, we're going to look at how you can figure out what the mass of 1 mole of any substance is. So as you can see from the picture, this is the element carbon, like black soot basically, and it is sort of the element that all the calculations began with. It was sort of the base unit. So 1 mole of carbon on our periodic table that we use, the Nelson version, the mass is recorded as being 12.01 grams if you have 1 mole of it. So this picture just gives you an idea of, how tiny atoms are, because again, look at that little petri dish, and you have to realize there are 6.02 times 10 to the 23 atoms of carbon in that little dish. You will notice occasionally with different textbooks that occasionally molar masses are not identical on one periodic table to the next or one textbook to the next. And that's because you can have different degrees of accuracy, which we've been talking about, so a different number of decimal places. Our periodic table always has 2 decimal places, as you can see from the 12.01. This scale here, probably isn't a super expensive scale, so it wasn't, perfectly dead on. Okay, so definition of molar mass of 1 mole of particles, and it's something in chemistry, obviously, so atoms or molecules. Sometimes if we just want to write a short symbol, you will just write M. You're not going to write molar mass, and it needs to be a capital. And because it is 1 mole of it, and of course we're going to be measuring in grams, the unit is grams per mole. Our textbook sometimes does it like this, g mole to the -1, but you can also think of it as just this, grams per mole. These are all the same. So I'd like you to look at your Nelson periodic table. And if by chance you don't have it, I have attached a link in our virtual learning environment. It's not the clearest, so I really hope you have yours at home. First of all, if you find hydrogen, so this is molar mass of hydrogen, so look in group 1, and in the box for hydrogen, the top right corner says 1.01. That is what a full mole of hydrogen would weigh. You'll also notice if you check out the little legend box that they have in the middle of the periodic table that you can see for this example iron, that it says 55.85, and beside that it says the atomic molar mass in grams per mole. So that is what you're looking for. So if we find calcium, it is 40.08 grams per mole. Just going to write it differently here. And finally, silver. Silver is in group 11, so 107.87 grams per mole. Okay, so if you're asked for the molar mass of an element, you just look at your periodic table, read it off. You will never be asked to memorize those. Now, I do want you to take note that our periodic table always has 2 decimal places. Okay, and don't round those off ever. Just that is how accurate our table is, so that is what you should express. Now, you'll often need to know the molar mass of a compound, or perhaps an element that like hangs out with a buddy. So an element, a molecular element, excuse me. So in that case, basically all we do is we add up these values that you're getting on your periodic table. So for instance, fluorine does hang out with a buddy from Hofbrinkel. So if we wanted to know the mass of 1 piece of fluorine gas, we would need to realize that there are 2 fluorines. So we would be multiplying 2, I'm going to do a capital there, 2 molar masses of fluorine is what we would have to figure out. So that is going to be 2 multiplied, find fluorine on the table, it's 19.00 grams per mole. And then you would do that on your calculator. And please don't just write 38. You have basically added up, like we've multiplied by 2, but it's like thinking of 19 plus 19. So you have added up 2 things with 2 decimal places. So your final answer absolutely should have 2 decimal places. Okay. All right. So for water, we're going to have to add up 2 molar masses of hydrogen plus 1 molar mass of oxygen. Now, I'm showing a lot of work here, and I certainly don't expect you to show all this work. It's just for learning purposes. You will get that you're just doing these straight on your calculator and not showing any work whatsoever, and that is fine. Okay. So this is 2 multiplied by 1.01. Also, I'm going to get lazy, and just when I'm adding these up, I'm not going to keep writing grams per mole, grams per mole, grams per mole, but in my final answer, I absolutely will. So an oxygen is 16.00. Okay, so then we can expand this. So 2 times 1.01 is going to be 2.02. Maybe now I'll throw some units in. Plus 16. Now you're going to add them up. So we're adding up 2 numbers that have 2 decimal places. So this is again where I'm saying you need to obey the rules of keeping the least number of decimal places, which is going to be 2 in either way, in either case. Okay, so 18.02. And we should, of course, put a box around our final answer. Okay. So one more example, just getting just a little more complex as we go. This is magnesium nitrate, and we have to think back to Unit 1 where, what does it mean when we have brackets in a formula and you have to figure out, for nitrogen, there's 1 nitrogen in the bracket, but there's 2 brackets. So that means you have to say 1 times 2, therefore there's 2 nitrogen, etc. Now, starting off, for magnesium, we just have 1 of them. So we're going to have 1 molar mass of magnesium. Now for nitrogen, 1 inside the bracket times 2 bracket gives us a total of 2 nitrogens. So we're going to need 2 molar masses of nitrogen. And finally, for oxygen, 3 inside the bracket multiplied by 2 is 6 oxygens. So 6 molar masses of oxygen. Okay, so then we'll fill these in. So magnesium, top right corner is 24.31. Nitrogen is 14.01. And then we'll be needing 6 oxygen, which is 16. Okay, so then we'll expand these. And I'll put some units in. So 28.02. Oops. And then 6 times 16 is 96. And if you carefully do that on your calculator, you should end up with 148.33 grams per mole, which is our molar mass of magnesium nitrate. Okay, that is it for today. Thank you for tuning in.